Welcome to the deep dive. So, you gave us this really interesting stack of sources all centered on one piece of gear.
Yep.
It's the Thor Broadcast F-4A-XLR. Well, the name is a
It
mouthful.
is, yeah.
But the point is, this system is built to solve one huge headache. How do you get 4 channels of pristine analog audio, say, from a live stadium mixer and send it 20 kilometers away with zero degradation?
And that 20-kilometer number is, it's really the whole ball game here. That's our mission today,
Yeah.
to unpack the tech inside this box that makes that possible.
Right.
Because with traditional copper cable, that kind of distance is just, it's a non-starter.
Mm-hmm.
So the big leap is moving everything on a single-mode fiber optics. That's the secret to that 20K guarantee.
Okay, so let's dig into that. 20 kilometers is a massive distance. How does it squeeze 4 separate high-quality audio channels onto one tiny strand of fiber?
So the secret sauce here is a technology called CWDM,
CWDO.
Force Wavelength Division Multiplexing. The easiest way to think about it is like a highway for light. But instead of lanes side by side, they're stacked, and each one uses a different color or a different frequency of light.
So you can send multiple signals at once.
Exactly. And what's really fascinating is that the design allows you to add other signals later, video, data, whatever you need, right onto that same fiber.
That potential for stacking signals is great, but we're talking about taking sensitive analog audio and turning it into light. How do you guarantee perfect clarity and timing across that huge distance?
That is the job of the digital core. It relies on something called an FPGA.
A field programmable gate array.
Right. And you can just think of it as a super fast custom beat translator chip. It manages the data. It handles the clock recovery to make sure timing is perfect.
So no jitters, no drops.
None. It keeps the signal totally stable. And thankfully for the user, it's still all plug and play. You just look at the little LED status lights.
Okay, so that's the data stream. But what about the sound itself? What are the specs that mean the audio arriving sounds just as clean as when it left?
Okay, this is where it gets really interesting, especially for any audio engineers listening.
Yeah.
The system uses a high sampling frequency, 192 kHz with 24-bit sampling. But the key takeaway, the real headline, is the 100 dB signal-to-noise ratio.
100 dB. What does that mean in practical terms?
It means the signal has virtually zero detectable electronic hiss. No background noise. It's just incredibly clean beyond typical pro audio gear. It's studio integrity the whole way.
Okay, the crucial practical thing. If this unit is 20 kilometers from the mixer, it still has to power the mics, right? High-end condenser mics need power.
Yep, it's solved right at the source. The unit includes 48V DC phantom power, which is the industry standard, and you can just flick a switch for each channel to turn it on or off.
Now, anyone who's done live sound knows that awful jarring pop when a mic gets turned on. What's in here to stop that from ruining a broadcast?
They built in what they call an intelligent noise suppression system.
Which is a fancy way of saying.
It's a fancy way of saying it has digital safety guards. It uses these soft rise and soft fall ramps, basically a simulated squelch that guarantees no popping sounds. It also has a filter to cut out any of those low-frequency thumps.
This really sounds like it's designed to be abused. It's not for a comfortable studio. It's for, remote stages, massive outdoor venues.
Oh, for sure. I mean, look at the operational temperature range. -20, all the way to 70 degrees Celsius.
Wow.
So this box can be working in a frozen parking lot or on a blazing rooftop. And it's rated for over 100,000 hours of work.
And what about just, a lightning storm?
It's covered. It has robust level 3 lightning protection. It can handle electrical spikes up to 6 kilovolts, so it's built for that field reliability.
So when you boil it all down, this device isn't just moving sound, it's translating incredibly dense, high-fidelity audio into light, and then protecting that light signal across a huge distance.
Exactly. It's a true workhorse for modern broadcasting.
It really is.
So here's a final thought for you to chew on. Given how flexible that CWDM technology is, how much other data beyond audio, beyond even HD video, could you theoretically stack onto a single fiber strand before you started to see any performance drop? That's something to mull over.